So the main goal today, now we have the notes, is how do we simplify square roots that aren't perfect? So to do that, we have two steps. Step one is list all the factor pairs. Remember that we always start with 1 times the number and go from there. Step two is going to be to look for the largest perfect square and then simplify, because we know what those are worth. So we'll do here 3 examples and check. Guys, before I do the examples though, one quick point. When you guys simplify with square roots, when you find the exact answer, that means that you leave the answer in simplified radical form. But if I ask you to get a calculator and get a decimal answer, I'm going to ask you to give me an approximate answer. So for today, we're going to focus on exact answers, but then on the next notes, we'll talk about doing both of these for each question. Okay, example G. Let's simplify radical 8 to its simplest radical form by looking for perfect squares. So again, step 1, list all factor pairs. So always start with 1 times the number. So 8 is equal to 1 times 8, but it's also 2 times 4. And then that's kind of it. So as you scan these different factors, do you see any perfect squares? Guys, hopefully you see that 4 we know is a perfect square, so I'm going to put a square around it. And I know that's going to be a 2 by 2 square, so I know that the square root of 4 is equal to 2. So once I identify a perfect square, it means that I can simplify this a little bit. So to do that, I'm going to take my original question and I'm going to rewrite it. But instead of saying radical 8, I'm going to put radical 2 times 4. So I get radical 2 times 4, which I just get from this factor pair. But I now know that 4 is a perfect square, so this comes out as just a 2. Leaving me in this question with this 2 left inside the radical. So I get that this simplified form is going to be 2 radical 2. Guys, 2 radical 2 is equivalent or the same value as radical 8, but it's simplified. And to repeat, all I did was I made a list of factor pairs. I looked for perfect squares, which I found one here, because we know what those are equal to. So the square root of 4 comes out as just a 2 with no radical on it. And this 2 happens to stay inside. Example H. Simplify radical 24. So step 1, let's make our factor pairs. 1 times 24, 2 times 12, 3 times 8 also works, and then so does 4 times 6. So in this case, I have some more factor pairs to look at, but now I want to look at them and identify, are there any perfect squares? So as I look around, again here, 4 is a perfect square, and this is the only one that I have. I know that the square root of 4 we know is equal to 2, so I can take my original problem and rewrite it as the square root of 4 times 6, because I now know that the square root of 4 will come out as just a 2, and then whatever's left behind just stays inside the radical. So this 6 stays in the radical, so my answer is going to be 2 radical 6. 2 radical 6 is an equivalent value to radical 24, but this is simplified. Alright guys, one more from me, example K. So as we start to mix it up and give you more complexity by adding exponents, remember that guys, a radical is like a grouping symbol, like a parentheses, so it links things together. In example K, this radical only attaches to the 3, so this 4 is not linked. So this 4 is attached afterwards, which means that this square only goes to this radical 3. So I can first focus on just this piece. But we learned above that a square and square root are opposites. So whenever you have a square and a square root, they're going to cancel each other out, those two symbols. So in this case, this square and this square root will cancel each other out. Now the 3 is still there. So what I end up getting is 4 times 3. And then once I do that, I get 12. And that's the answer to example K. Guys, one more thing I want to show you, just to give you the correct, or the other variation is, please understand that when you have a square root, I can also write it as a fractional exponent. So the square root of 3 is the exact same as saying 3 to the half power. Okay, we're going to see this more and more. So if I did this in this example, and this is a little bit more advanced, but I'll show it to you once. I can say this is the same as saying 4 times 3 to the half, and then squared. Now, if you understand this, then if we think about our exponents as lists of repeated multiplication, here, this means that I have two of these. So if I have 2 3 to the halves, then if I have half of a 3 and half of a 3, then I just have 1 3. So this becomes, like we did before, let me erase this real quick. This just becomes, again, 4 times 3, which is still going to be 12. Now guys, this last note's a little bit more advanced, but if you just go to what we did before, just know that when you have a square and a square root, those symbols cancel, leaving the 3 all by itself times a 4, and you get 12.